Hello everyone, I am Bradley Sward, Associate Professor of Computer and Information Science at the College of DuPage in Glen Ellen, Illinois. In this video today, we're going to crack open the C++ programming language as always for this course lecture series, and we're going to make a simple coin class. You know, you have a heads and a tails, so let's discuss how we would set up a coin object that we can, basically flip and figure out and keep on flipping and figure out if we have a heads or so. Here is the problem in its full glory. We're going to develop a class called coin. We're going to have one member variable, which is the Boolean. Is it heads or tails? That's pretty simple stuff. We're basically maintaining that one variable under the hood. And then the big difference here between a structure, this would be a structure up to this point, and everything that comes after it here is what makes the structure basically an object. And of course, let's not talk about all the details that make that a 100% not true statement. But for all intents and purposes today, that is good enough. We're going to set up all this functionality to go with it so that we can basically call these functions on this object and have it maintain and change its state. And so when we're done with that, we're going to test it out by basically flipping the coin a lot of times and making sure that everything comes out as close to 50-50 as we could imagine. Because if we do something wrong and it comes out 100-0 or 75-25 or anything like that, then something is probably amiss. But in this case here, if we get this and we get 50-50 results, 50% heads, 50% tails, then we know we're on to something good. Okay, so the big difference for what we're going to be doing in object-oriented programming forevermore when it comes to how we deal with object-oriented programming is we're going to take the stuff that's actually the coin class itself, because this is the source, this is going to be the main file, and we're going to start moving everything over into header files and implementation files, because that's the big difference here between object-oriented programming when it comes to just making sure that we start putting all our code in different places instead of just main or just a couple functions. Now we're going to start spreading our wings here. Oops, not existing file. And we're going to start creating all sorts of new stuff to throw on top of everything. So I want to start with the header file because that's where the header goes. And we're just going to, of course, coin.h. You need that pragma.once. If you're used to include guards, that's what this thing is. This is just a Windows-specific include guard. And again, I'm not going to get into all the details, those details just at this exact moment in time. Okay, so here is our to-do list with this. I'll just leave it down here. And so develop a class called coin. Class coin. Okay, I wish it was that easy. Done. I really do wish it were that easy, but we can't go ahead and do that. But that sets up the structure. And so kind of remember when we were dealing up the actual struct, that we have private and public, and we're going to learn protected in chapter 14 as well. So this is where data hiding and we also encapsulation rules. These are all conventions, but if you do things correctly, at least in C++, you're not going to have bad times when it comes up with basically security of your data. So I'm going to have a public section, I'm going to have a private section, and this bool is heads. That is going to be, I could have said is tails or is heads, or I could have named it, I could have used something other than a bool, but it makes sense to use a bool here because it's either heads or tails. If I was using something that had maybe, three, and maybe you've seen this over the years that someone actually flips a coin and it actually lands on its side, or it lands in a way where you can't tell if it's actually heads or tails. Like, yeah, if you wanted to really account for that, like that real world effect, yeah, you would have to do more than what we're going to do here. But there's my private variable, and then we say we're going to develop these functions. I'm going to develop the constructor. The constructor always has the same name as the name of the class, and the constructors and destructors do not have return types. So, this is going to turn green because we have to actually do the header, but then we have to do the implementation. We actually have to set up and write the code for these functions. But the header itself, the goal of the header is to give the end user, which is either yourself or other people using this code, the official API. And you're not going to give away your source code. Why would you give away all your hard work? you want to give away access so people know how to use it, but you know, all that secret stuff that you did to make this thing work, no, that's not their business. That's your business. And if they want to see it, maybe they should at least ask you or pay you some money. So that's just kind of how things go here. Okay, so I have that. There's my constructor. And I'm going to have this isHeads function. It's a bool. isHeads. And I'm going to do the const correctness here. Let me just write out the two here, his heads and his tails. Okay, so these are going to be bools, because if you had a coin sitting on the table and you couldn't see it, and you were asking your buddy, hey, is that tails? Is that heads? You would expect a yes/no answer, and depending on the friends you have, sarcasm and whatever else to go with it. But from the computer standpoint, it would just be a yes/no, true, false, is it heads or is it tails? And the reason why we throw the const at the end of this, for both of these, is that I'm just asking someone, hey, is this thing heads? I'm not telling them or asking them to change the data, change the state of the coin in any way. I'm only asking them to look at the coin and tell me what's going on with the status. So when nothing changes, or the presumption is that nothing's going to change by calling this function, we make the function const. So that is completely different from the flip function, because the flip function basically is telling whoever is the master of the coin to go ahead and flip it again. Maybe it'll turn heads, maybe it'll turn tails, 50-50 shot, but I can't obviously guarantee that the state is going to stay the same. So we're going to make it a non-const function. And the same for toggle. I can absolutely guarantee you that it will never stay the same, because if it's heads, it'll turn to tails, and if it's tails, it'll turn to heads every single time. So that is everything when it comes to setting up the actual, minus a couple comments maybe. Here are the good comments, but everything we need to do to get the header going. And then the final step now, at least on the coin side, is to start writing the code and figuring out how are we going to make all of this work together. Okay, and if you're using Visual Studio, one easy way you can kind of make this work is you just kind of go over here, you highlight it all, you right click, you do quick actions, quick actions and refactorings, and you tell it to create the declaration and definitions. And for some reason it doesn't work for me, but it would work for you. And it does create the file, the CPP file, but it doesn't, for whatever reason, I'm getting an error, and I don't have the time right now to figure out what the heck's going on. It's probably because I've been, this is such a Frankenstein solution inside of Visual Studio, at least for me, that I copy paste this thing hundreds of times when I'm going through all your work, that maybe just maybe there's a dependency issue, which I wouldn't doubt at this point. So if we're going to write the functions for this guy here, now I can actually take this and bring it both on the same page here. Here we go. So now you can kind of see there's our coin class, and here are all our coin functions. And now I guess I'll just copy paste it the old-fashioned way. There we go. And so now we're going to implement these functions on this side. We have to tell the compiler that these functions apply specifically to the coin class. And that's why I'm throwing coin : : in front. You know, we've used std : before for a lot of things. And so it's the same basic idea, except that std : is a namespace, and this is basically an object space or a class space, if you want. There's no real name for that, but that's just kind of what's going on there. And I'm going to add the body of excuse me. I'm going to add the body of code here for all the functions. And all this hard work now, all this boring hard work, would have been done for if the compiler didn't have a bug up its butt. Okay, so there is everything, and I don't know why this is having an issue. Declaration is incompatible. Maybe it's just because IntelliSense is having issues with things at the moment. I'm not 100% worried with this error message right now. Okay, so let's go and complete and finish up everything, and then we can go ahead and do our work here. So we have a heads object that maintains this isHeads variable, and now this functionality. So when I create an object, it says set the state to heads every time. So what that means is, and let me just do this the old-fashioned way. If you're coming from a Java or Python background, you would just say isHeads equals true. Because no matter what, every time I create a brand new coin and I hit this constructor function, and the job of the constructor is to set up every variable to a valid state, and to not leave anything hanging or dangling or anything where trouble can come around. Because if you forget to, you can have a bool which is, true or false, but you can actually have a bool that is just uninitialized. And if you forget, you're gonna have a terrible time using that object, because it's not going to come up in a correct manner until you actually go and flip the coin. So is heads is going to be true. And again, if you're coming from a Java background, you go, what's wrong with this? And I go, there's not necessarily anything wrong with this, but we do need to use the initializer list for these kind of things. It's more professional and it's a little more efficient and all those other things that go with it. And it's pretty much a C++ thing for the most part. C# has it, Java has it a little bit, but the initializer list is a little different than the way the other languages handle things. And it's weird because then you don't have to have anything here in the actual code block. The initializer list takes care of the one variable. So when I hit this closing curly brace and the constructor is done, this object is constructed and the variable is in a valid state in a way that the rules of what we're trying to set up are obeyed. So the state is going to be heads every single time. So now we can just say here for the isHeads function, we're just going to say, hey, isHeads true. And we could simplify this, but I just want you to understand where I'm coming from with this. And because remember, the double equals, all these relational operators return bools. So is heads true? Yes or no? And if it's true, then yeah, it'll return true. And if it's false, it'll return false. So this is all we need to get the job done. And on the other side of this, you could do things two ways here. You could say is heads equals false, right? That's the only, because then if it's not heads, it's tails. So we could do that. But what we do a lot of times, especially when we start thinking in the terms of libraries and things like that, like I would like to make it simpler. I could just say return not is heads. Right? Because I say, is it heads? If it's heads, then it's not tails, so let's flip it over. And if it's not heads, then it is tails. So by taking whatever this function returns and just flipping the result, turn a true into a false and a false into a true, I only have to implement the code in one place, and then I access it from inside of here. And I said, of course, you can't always get away with that, but in this case, you absolutely can. And again, the point of all of this is to write as little code as possible. I didn't duplicate my code, or in this case, have code in two places. Because if something goes wrong, either my logic is wrong or just something's not working right, I then have to remember to fix it up in two places. But if I write the code this way, I only have to work and fix up this code right here in this one place. Okay, toggle is the easier of the two. So of course, whatever is heads is going to be equal to whatever the opposite is, right? So that's all there is to this toggle function. And so just kind of remember also, when we came back to this idea of the initializer list, is that this is only good for constructors. It's not good for any other type of function. If you try to do that, if you try to put that in here, you will get a compiler error. I don't know what the error you will actually get is. Let's just see. Expected a set. Oh, yeah, that makes total sense, right? So don't do that. Don't do what Danny Don't does, and you won't have to worry about that. This initializer list is only valid with constructors. Okay, so here we go. I don't know why this is coming up, but we'll figure it out. We'll get there when we get there. Okay, so the flip is the only thing that kind of is slightly challenging, and we're going to need to include basically rand for this. So I can just say isHeads equals basically, and this is where C++ gets a little weird. I can take rand and I can mod it with 2. And the only question is, yes, I'm going to need to include wherever rand is, and I think that's the C standard library. Let me see if I can find that real quick. See if I can find that quick. And C++ rand is inside the, okay, C++ is inside, yep, C standlib. So we'll include that here. All right, and then rand should magically start working again. And I can get away with this because in C++, this will be an implicit conversion from an integer into a bool. And this function will only give me values 0 or 1, right? That's what mod 2 means. Take an integer, divide it by 2, and give me the remainder. The remainder is either going to be 0 or it's going to be 1. Because, any number divided by 2, 7 divided by 2 is 3.5. The remainder would be 1. 8 divided by 2 is 4, with no remainder. So that it would be a 0. And in this case, it's a 50-50 shot either way, so I don't necessarily care. If it were, maybe it'd be a little different if there were different possibilities for things. But with a 50-50 shot, just throw in a 0 or a 1 into the is heads and call it a day. That pretty much solves our problem. And now, what happens if I build this? I'm so curious now. There's an actual problem here or not? Oh boy. Redefinition. Oh, I do this. I have a tendency to do this where you're like, what is going on here? What is the problem? And this happens occasionally across all languages when you start working. And this is the first time I saw this, I'm like, what the heck is wrong with this? There's nothing wrong. The problem is that the compiler can't figure out this is heads versus this is heads. Even though this is a function and this is a variable, it doesn't know when it looks at this and it goes, okay, this is supposed to be a function, but this is supposed to be a variable, and it just literally here flips out. So I'm going to rename this, and I can rename it here. I'll just call it is heads now. And I can apply it across the board. And now there goes everything. I think now everything should be, almost there. What did I do? It did. When it did it, I did a blanket statement here. Okay, the problem here is heads now is not the function, is heads is the function. So now I fixed this up. So that's the first time I've ever had really an issue blanket changing things. But you got to watch out. Now I have two, and this is again where warnings are a problem, because this is saying, are you sure you want to do this? Are you sure you want to take an integer value and turn it into a bool? And I go, yeah, but just to be on the safe side. This is why there's warnings and stuff like that, because it's basically telling me, hey, if you really want to do this, you should go in and fix the code up so that if there's a problem and, return value ignored. Interesting. Let's see about this now. Did I intend equals? No, I didn't intend equals. Oh, yes, I did. Did I put that double equals in there earlier? Oh, boy. If I did, my greatest apologies. I just figured it out right now. Boy, boy, boy. Big boy pants for me. Okay, so there we go. And now that actually works. This will convert the 0 or the 1 into its actual bool. And again, a lot of languages won't even let you do this without this cast. So the fact that C++ did it as a warning and not even as an error, that kind of speaks to the language itself, because C++ is old and all that. So this converts the integer into a bool, and as long as this is just 0 or 1, it'll always come out correct. Okay, so now the only problem that comes up is a linker error, because as we were doing this, we never set up a main function, and that's now, the class now itself is done. All the things that we need to do. This maintains these two functions maintain the ability to see what the value is for the coin at any time. This thing sets it up, and this thing allows us to modify it in different ways. So we, basically for a simple implementation of a coin, everything is ready to go, and now we're ready to do our job here with the flipping the coin a ton of times to make sure it's working properly. Okay, so now that we're over on the main side, now we can use this thing and get to, basically start going to town here. So let's see. What we're going to need to do is we're going to need to include IOStream for sure. We're going to start printing stuff out, so we're going to need IOStream. And I'm also going to need to include the coin class. Even though these things are in our Solution Explorer, this just tells Visual Studio which files need to be compiled and linked. It doesn't say anything from the standard of the source code itself, which files need to use other files to get the job done. So this is where we're going to, and notice that the chevrons or the angle brackets are what we use for libraries written by the C people, the C++ people, and generally speaking, the quotation marks are used for code and classes and objects and files written by us or somebody like us on this end of the thing here. So, okay, so there we go with that. So let's set up an int main, not a void main. We'll return 0, and I will put in a system pause. Okay, so I will set up a coin. I'll just call it C. And let's go ahead and let's just check this thing out. Let's see how we will go ahead and do this actually. Here, let me pull up that CPP file and drag it. That CPP, there we go. Okay, so let's run this. Put a debugger in here. Put the debugger going. Okay, so we've hit the debugger. We're trying to create this coin object. I hit F11 to go in, and see it hits the constructor. It sets the variable isHeadsNow to true. Now it's true. It was uninitialized a moment ago, but now it's good to go. And now you can see with this coin C, you can see isHeadsNow is true, and we're not doing anything else with it, but you can see that the constructor did its job. And if we set up 10 of these things, you would see that everybody has their variable, their member variable sitting under the hood set to true. So I think the constructor is doing a good job there. Okay, cool. So then what I want to do from there is I want to flip it. I want to flip the coin, and then I would like to print out the result of the flip. Just to get used to using the functions, and I say C dot is, well, I guess the question is the result of the flip heads? And I'll put that in all caps just because I like screaming. Is heads, and then put an end line. And the same thing can go here. How about tails? Of course, they should always be exclusive to one another. An exclusive or, it can't be both. It's one or the other, always one or the other, but never both or never neither, right? So let's see what happens now when I run this. And I will run it through the debugger one more time here just to show you here. So now I don't need to go through, I'll go through the constructor one more time. You can see it working. And then now the flip function, isHeadsNow true? isHeadsNow is still true. So, okay, so the flip of the coin didn't really change anything when it comes to the data, but we flipped the coin. And now we're ready to print. And you can see there, oh, you can't see that anything here. Here you go. So since the flip is heads, it comes out as heads, and it doesn't come out as tails, and then system pause, and we're done. And you could also, and you could test this out too the same way here. Instead of just testing it, you can do a toggle. Testing your code is a big one, right? Right, guys? Right? Agree with me, please. So now it should definitely come up the other way. And here we go. Oops, here we go. So it goes heads is one, and then when I toggle, I flip the heads to tails, and obviously the zeros and the ones, because now everything has flipped its logic, and now we're good to go. So let's see. Constructor works. Is heads, is tails works, flip and toggle work. So we're pretty confident. Again, we only tested these things out a little bit, but it's a simple enough piece of code here. At least under the, if we took away the object-oriented programming that's new to you, the logic of what we're doing with this coin is very easy to understand. So now it's just a matter of flipping the coin a series of times. So let's set up this coin. We're only going to use one coin object. And so in this case, I'm going to say int heads equals 0, int tails equals 0. And we're going to flip this thing 7 times. And so, okay, so we're going to do this 7 times for int I equals 1, I is less than or equal to 7, oops, plus I. We're going to c.flip. We're going to flip we're not going to toggle the coin, we're going to literally flip the coin. And if c.isHeads is true, I'm going to go ahead and increment heads, else I'm going to increment tails. And yes, this says, you know, basically in baseball or any sporting event, at least in America, where they play playoffs and that sort of thing, that if you win the series, if you sweep the series, if you know, World Series playing 7 games and you win 4-0, you don't play games 5, 6, and 7. There's no purpose. But in this case, I'm trying to keep things simple for you. If you really want to go ahead and just keep this logic going until someone flips 4 times, and you know, heads is 4 or tails is 4, but it doesn't hurt to just flip 7 times and see who won at the end of the day here. Let's just kind of finish this off. My idea here: number of heads, and then heads with an end line. Steal this bad boy here and bring it up number of tails. Try again. Let's see what happens. All right. Tails wins 4-3. It won game 7, won the 7th flip. Anybody want to bet on this again? I'm going to bet on tails. And okay, there we go. We got tails. I'm going to bet on tails again. Tails can't. There's no way. Or do you want to bet on heads? I'm going to bet on tails. I'm going to have a winning streak. I'm going to keep on going. Winning streak, winning streak. And this is what this is part now. You want to keep betting? You want to keep losing? I can do it all day. I'm going to keep betting heads. Double or nothing, double or nothing. You will never win that bet because the random number generator always is going to give us the same string of random numbers. It's pseudo-random. It's not truly random. So if I want to go ahead and do something where I can't win every time, now that I know this, I'll have to set up a srand time. I think it's static cast. Unsigned int time null pointer. I think it's, or is it null? Let's just see what it null pointer. 1, 2, 3, 1, 2, 3. Let's see what it does here. And now can I run this? I think it's gonna run, and it does. And now we get the same result. Let's see if it, come on, give me something different. There we go, finally. It does, now it gives me something different every time. 5 heads to 2 tails and whatnot. Now 4 heads to 3 tails. So yes, we're gonna get some kind of difference. And of course, since we're flipping a coin 7 times, what are the odds of getting a 7 to nothing? 64 to 1, something like that. One way, if you wanted all heads, it's 128 to 1. If you wanted either one to be 7, it's 64 to 1. So now now we have this working for one series of 7 flips, and so now we said we're going to do this 1,000,000 times or 10 million times. Or int j equals 1. J is less than or equal to 10 million, and you can do this now in C++. I don't know how long you've been able to do this. But you can use, instead of commas, because commas are, different, you can use the single quotes as dividers for your numbers, because that looks a lot easier to read. That's 10 million. I can get that. Okay, so I don't need this. I don't necessarily need this anymore, but I'm going to change this up in a minute anyway here. So I'm going to do this 10 million times. I'm going to flip 7 times, and then here is where I'm going to do the code to say, okay. Because number of heads, number of tails for this round, well, how many rounds has heads won, and how many rounds has tails won? Oops, I need to obviously put an int there. Okay, so I don't need to change any of the inner code, at least with this stuff, because this is what gets me the end result. And now, when I come out of this loop, if the number of heads is greater than or equal to 4, because that's what we're doing here, I'm going to increment round heads. Let's have IntelliSense help me set it up here. Otherwise, again, it's one or the other, at least in this case. So this is where I can say rounds tails. And now I come out of the loop here, and then instead of just heads, now I can do rounds heads. And I could do rounds, tails. And if I did everything right throughout this whole program now, these two numbers should be very similar when it gets done. And I don't know what's going to happen since I haven't tested this. So it's running, 10 million times, 70 million flips. And you can tell it's running because the cursor is flashing. Oh, I wasn't expecting it to take this long. There we go. And now you can see that 5 million, very close to 5 million. Of course, it's not going to be 5 million exact, right? That's the joy of random numbers. That's the joy of the randomness of the universe, or at least according to what we understand of classical versus quantum mechanics and all of that kind of stuff right now. So very close. And you could try this again. So the fact that it runs 10 million times, it gives me a number very, very close to 50-50. That tells me that this coin is pretty good. It's not perfect. Rand is not good for general kind of stuff. Now you can see it's the other way around. Heads is a little more likely, but my goodness, think about that. We're at the 4th decimal point. 50.0002% versus 49.9998% when it comes to this. Like, that is well within the realm of possible error that this code would be allowed to have and still be considered random. You know anything like the way statistics work and all that kind of stuff. This is very, 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 very statistically relevant, that it's very, very close to one another 50-50 shot. Okay, so that covers basically the entire program, how to set up a coin class, how to create a header in one file, how to create the implementation of that, of all the functions in another file, and how to use all of that in the main. And now this coin is reusable, because all I have to do now is copy coin.c and coin.cpp into all other projects, and I can use this. If I didn't do it this way, if I put everything in one file, the coin could never be used again, because that main code would be stuck with the coin, and you obviously can't have a program with 2 mains. Or what if I have 3 other objects? You can maybe see where these problems start coming around. So anyway, thanks for sticking this video out with me here today. If you have any questions, please comment below here on YouTube, or send me an email at swardb@cod.edu. And of course, I'll get back to you as soon as I can. So this is the fun of data hiding and encapsulation. This is chapter 13 stuff for the book I'm covering, and it's basically just the beginnings of everything. Chapter 14 is where we get a little more advanced. We start dealing with copy constructors and move we talk about it at least. Move instructors and stuff, move constructors, destructors, and other things like that. Operator overloading. Chapter 15 is where the big power comes from, inheritance and polymorphism. How can we make this thing work? How can we write as little code as possible and make the code work in a manner where we can set up so that we can have different types of coins, or we can have different types of cards, or things like that, where we don't have to reinvent the wheel every time we invent a new type of playing card or a new type of coin. So that's where we're going with the rest of this semester, and that's where we start in the advanced C++ course, and then of course we push off into data structures from there. So Thanksgiving week where I am right now, so happy Thanksgiving if it just happens to catch you at the same time. Otherwise, have a great day, have a great week. I hope to see you guys in future videos. Have a good one, everybody. Take care.